It's impossible to write efficient trading algorithms without understanding the data structures that go into them. So in this video, we're going to talk about what data structures are, why they are useful, how to work with them in Python, and then some examples of how to actually apply them to useful things in research and trading. First, let me introduce myself. My name is Ben. I'm a software engineer and algorithmic trader. I traded equities, derivatives, and crypto, and I'm currently building the Python for Traders community for quants, traders, and engineers that if you watch to the end of this video, I'll show you how to join for free. So let's get into it. What are data structures? Basically, they're just a collection of information that is structured in a particular way. And that structure of the information affects its behavior. When I say behavior, I specifically mean how efficiently you can read, write, edit, and delete from that data structure. To make this idea clearer, I'll give a real-world analogy. So think about a library. And when I say library, I mean a real library with books in it and not like a coding library or something like that. But imagine a library and think about how that library organizes and orders its books, right? Each book has a unique identifier. Usually it's some sort of alphanumerical code. And those identifiers are grouped by the book's genre and probably its title or its author also. Then each shelf holds a range of identifiers for that type of category of book. And this organizational system comes with a number of advantages and disadvantages. So the advantages are that it's very easy to find, remove, and replace books because you don't have to go one book at a time. Imagine that if you had to start all the way from the beginning and go one book at a time to find any book, it would take forever. But with this system, you can very quickly filter down to your genre first and then your author name, and then you only have to search one book at a time within your particular shelf to actually get to the one that you want. But the big disadvantage of this system is that when a book is returned, the librarian has to go one book at a time and find its location and put it back by hand. So you can imagine that this is a lot slower than, let's just say they had a single pile of books, right? That would be the least efficient data structure probably, but the simplest one to maintain, which would just be a pile of books or a randomly organized bookshelf, or something in between, right? So this library example is a lot like a data structure. And in particular, this one would have fast reads, so you can get information from it very quickly, and slow writes because it's a little bit harder to insert information into it. So in this video, we're going to go into some examples of these different data structures in trading applications. But before we do that, let's do a quick tour of what they are and how to work with them. So the three that I'm going to cover here are lists, sets, and dictionaries. There's a fourth one in Python called a tuple. I'm going to leave it out for now because it's pretty simple to understand and it's less interesting in this context. But this will just be a fast treatment of what these things are. And I really want to get to the applications part. So for a more detailed breakdown of the performance, and particularly the time and space complexities associated with different operations in these data structures and how they impact how quickly your algorithm runs and how effective your system is, come join the community that I mentioned earlier. The link will be in the description to the video. So the first one that I want to talk about is a list. And a list is just an ordered collection of items. It's quite literally like the name, a list. And there's an example here of 1, 2, 3, 4, 5. Defined with these square brackets creates a new list in Python. A list can contain any data type that you want. So here it's numbers, but it could contain strings, some more complex data types, or it could have multiple different data types at once where you have numbers and strings all mixed up. It doesn't matter. And then with a list, items can be added and removed so they can grow and shrink in length. Here's an example of how you would define one and use one in Python. This is very, very simple. Again, you just use these square brackets and you can type in the list directly. You can also generate lists from lists and do more complicated things, but this is the simplest way to get started. And then to get an item from the list, you use this bracket syntax here. So when I say my list 1, that will get me the second item in the list. Piece of kind of trivia or important piece to understand is in computer science, the first item always starts with 0. You always start counting at 0. So the item that's indexed by 1 is actually the second item in the list. You'll get used to that pretty quickly. Then here's some quick operations. We can always append to the list. This will add a number to the end. We can also remove an item from the list. This will remove that item by value. And then if we look at the final result of the list, you'll see here that we end up getting 2, 3, 4, 5, 6 because we added the 6 to the end and removed 1 from the beginning. So that's how you can grow and shrink the list. The second one is a set. And a set, unlike a list, is now an unordered collection of unique items. So a set can never have a duplicate item. Python will instantly be able to tell you if a value is inside or out of the set. So it takes no time at all to do that. And just like before, items can be added or removed from a set dynamically. Here's an example of defining a set. It's very similar to a list, but now we use these curly braces here to indicate that this is a set. And here are some quick operations you can do with it. One, you could check to see if a number is in the set. So here it's 1. You can add items to the set. Here I've added a duplicate item, so I've added 6 twice, and we'll see in the output that it's only there once. And then here you can remove the number 1 all the same as we did before. And if we look at the result, you'll see we have our 2, 3, 4, 5, 6. And again, the 6 was only added once because every value in here stays unique by default. The last one is a dictionary, and a dictionary is kind of like a set, but now instead of just having unique items, you have a collection of key to value pairs where all of the keys are unique and the pairs can be any sort of thing that you want them to be. So you can imagine a real dictionary, right, where you have this mapping from a word, which is basically just a string, to a word definition, which is also basically just a string. It's the same sort of concept where you're just mapping a key to a value. Here's an example of a dictionary, and in this case, all of our keys are strings or characters, and all of our values are numbers. So the value A will map to 1, B to 2, and C to 3. And we define it with the same syntax actually as a set, except we obviously use this colon to map the key to the value. Then to get a value by the key, you can just index it by that key itself using the square brackets. We can also add a new one, so if we wanted to add the key D and have the value 4, we can do that here. And we can also remove a key value pair by using this del keyword, which is short for delete. And then we'll have my dictionary A gets removed, and this is the final output down here. So that is kind of the quick tour of those three data structures. Let's get into some actual useful applications. So quick question, like where are these data structures useful? They're useful everywhere because data is everywhere in trading applications. So you can imagine orders, trades, prices, positions, asset data, all of that is a different piece of information that needs to be structured and organized in your program. So let's look at some examples of how these basic data structures can be used to do that sort of thing. So the first idea that I want to show is how to use a list to track trades for an asset. So here we have a class that defines a trade object. It's very, very simple. If you're not familiar with this kind of class syntax, basically this is just a grouping of fields where the fields that we have are going to represent a trade that happened in the market. And we'll look at the security, the trade type, so that's buy or sell, the price, and the quantity. And then we'll store all of those fields on the object itself. And this function down here stands for represent. Basically, if we want to print out this object, this just defines how it will be formatted at the terminal. So what we can do is we can define a list here. So this is an empty trades list, and we'll just make up some trades that happened. We'll say trades.append like before. So we're going to add to the end of the list, and we'll add in the trade object itself. And you can see here that we've annotated it with some comments that just say, we're buying 10 units at a certain price. Here, these trades are just simulated. It's like as if we were buying SPY, basically. And then what we can do is we can write a for loop to iterate over all of those trades. And in this case, we're just going to print them out. We're not going to do anything fancy with it. But you can see how this data structure right away makes sense for trades because they happen linearly and chronologically in time. So it makes sense that they're in an ordered data structure that can grow and shrink. The next example that I want to show is using a dictionary to track market prices. So now, instead of just looking at one set of trades or one list of trades, what if we wanted to track prices for a set of assets and we wanted to do it very easily and quickly? A dictionary is a very good data structure for this because it lets us map a securities ticker, like Apple or Google, to its current market price. So here, we're going to define the dictionary upfront with starting prices. And then what I've actually done here is I've written a handful of code to simulate the evolution of those stock prices over time. So what I've got here is some code that will implement Brownian motion, which is basically just a model for simulating the evolution of stock prices under randomness. Don't worry too much about it. But we have a function here that will simulate price, and that simulate price function will use some random variables to evolve the stock price over a number of time steps. Finally, down here, we're going to loop over 10 different seconds, basically. And again, this is all just a simulation. But for those 10 iterations, we are going to calculate a new simulated price for our security. And then we will store that new simulated price in the market prices dictionary indexed by that security. So we're going to constantly be updating our dictionary with the latest price. And then once we've done that, we'll print out each security and its price. So we get a sense for what the data actually looks like over time. And then down here, I have this called a time.sleep. So it'll do it every second, basically. So you can imagine that if you had a real exchange feed, this would be a good way to represent all the different market prices for all the different assets. So when I actually run this code, you can see here that each second it will update our prices. And we can very quickly say, okay, for each security, what is the current price that it's trading at? And if we ever wanted to just get the price for a specific security, we could do that instantaneously just by looking it up in the dictionary. So this is a very convenient way to do that sort of thing. Now I want to take it to the next level and basically show you how you can combine these data structures to create something more powerful. So in this case, we're going to look at how to use a dictionary with a list to track trades across the entire market. So basically combining the last two examples. Now we have this dictionary called market trades. And here it's a dictionary where all the keys are still strings like before, representing the stock, but the values are actually empty lists. So we're going to start off with an empty list and then build that up over time in the dictionary. And what's really interesting about this is we'll be able to kind of constantly modify these values so we can always look up the trades for the stock instantaneously. So the way it'll work is I've got a couple functions here. The first one is called add trade. This one's very simple. It basically just creates a new trade object like before. And then what it does is it takes the dictionary market trades, and then it looks it up by the key for the security, and then it appends to the end of the list. So this operation here, this market trade security, I'm sorry, my highlighting is messed up. Yes, this market trade security value is a list. So then we can call a list function dot append on it and get that value back. Then we have some code here to simulate random trades again. Don't worry too much about this. Basically, it's just going to pick a random security and decide whether to buy or sell in a certain random quantity. And then we'll simulate those random trades. We will call down here I forgot to mention this, we will call add trade at the end of this to modify the new trade dictionary. And then we'll just simulate the random trade multiple times, and we'll print out the results. So this is what that looks like. So you see at the start of the timestamp, we have one trade. It's just a buy order for Tesla at a certain price. And then in each timestamp, we get a new kind of addition to each dictionary for each thing. So you can see that this grows quite a bit. It's a little bit messy down here, but at the end of the day, we have, a mapping, again, Apple, Google, Amazon, Tesla, to a list of all of the trades that occurred for that particular stock, which is very, very useful, right? So that's kind of it for the core examples that I wanted to show here. Again, this has been a very basic overview of just using the primitive data structures. But if you were to go further and start to do this in practice, you could always use more custom data structures like a pandas data frame in a series. So the three that we described in this video, the list, the set, and the dictionary, are all native to Python. They are part of the programming language. And you can do infinite things with them, but there are data structures that are more specialized and are particularly useful for market data. So like I mentioned in pandas, which is a data science library, there are two objects. One is called a series, which is like a supercharged list that lets you do statistics and very fast operations on it. And the other is a data frame, which is like a better version of a spreadsheet that's native to Python. It's very easy to go between these native Python data structures like a list to these pandas data structures. Most quants will spend most of their time working with the custom data structures in pandas, but you need to know the native ones that we talked about here to understand the more advanced ones. So I'll quickly show some of that. So here I've imported pandas, and it's traditionally imported as PD. And then what I've got here is a list of trades that I'm going to build up from the market trades in the last example. So basically, we're going to take all of that data that was structured from stock to list of trades and repurpose it in a data frame. So I'll first create this trades list, and then once I have kind of a raw list of all trades, I take this trades list and I put it into a pandas data frame. And in particular, I'll set the index to be the timestamp, and then I'll sort it by that index. And you can see down here, this is the result. So first of all, when I have a data frame, it gets neatly formatted in my notebook editor, which is really nice. So I can easily read this, and it does look like a spreadsheet, right? And you can see here that the index is the timestamp, so that's the unique identifier. And then the columns are the security, the type, the price, and the quantity, right? So I have a clean list here of all the different things that have happened in the market. And now I can do very interesting and powerful things with this. For one, let's say I wanted to get all of the trades that happened for a particular stock. So like just Tesla, for example. I can index my data frame by using df, and then here I can say everywhere that the security column in the df is equal to Tesla, pull out that value. And that gives me the Tesla buy orders right away. In this case, there were only buy orders, but it would give me all the orders just by doing this. So it's very similar to like we did before, where we were looking stuff up by a particular stock, but now we can do it by any sort of column value that we want. And we can do the same thing, and this is something we actually couldn't do in the last example, but let's say we wanted to instead look at all the buy or sell orders. Here we can do the same thing where we say the type column is equal to buy. And now we have only the buy orders across the entire set of data. So this is very, very powerful. And it would be a good exercise to think about. In the last example where we had that dictionary with lists inside, how would you do this sort of thing efficiently using that? And there's no simple answer, right? Well, there is a simple answer, but there's no efficient answer. You would have to basically iterate over each list, do an if statement to see if there was buy order, and then append that to a new list or something like that, right? So this is a very easy way to do that sort of thing in only one line of code. So that's why these data structures are so powerful. And there's a lot more that you can go down the rabbit hole of here, but that I'm not going to get into today. So that's a wrap for this video. Like I mentioned earlier, Python for Traders is a community of quants and traders who want to learn Python to automate their trading and upgrade their skills without pulling their hair out from different technical rabbit holes and stuff like that. The community will be free for life for the first 100 people to join. So I really recommend you join now before we hit that milestone. So come on by if you want to connect with other quants, learn from our courses and trainings, and get access to bonus materials and myself. And if you want to join, you can go to pythonfortraders.io/p/community, or you can use the link in the description below. So anyway, thanks for watching. I hope you enjoyed the video, and I hope to see you there.